Hello, my name is John Fair, owner of I-Beam Sliding Door. Today we're going to assemble an incredible swing door. Let's get started. So I want to start with the parts and pieces that come in the kit with the incredible swing door. First off, we're going to start with the brushless servo motor, pre-assembled in the control box, pre-assembled hardware, the center hinge bracket, horseshoe plates, all the pins, jack plates, all the wiring. It's already connected cabling, instruction manual, control box, remotes, pre-assembled and assorted hardware, mounting hardware, bottom seals, side seals, pre-assembled verticals, and the horizontal frame. Okay, so first step on assembling an incredible swing door is I like to pre-assemble the motor to the jack. You can do this up on the building, up on the wall, but I like to hang this all one piece. It is heavier, but if you can hang this in one piece, it makes assembly a lot quicker and easier to do. Okay, so the rubber spider goes in the coupler. Okay, so then we're going to install the motor to the jack. So you want to do this with the grease slot oriented up. So then when you put the motor on, you want the motor housing towards you facing up. This would be on the inside of the building. So the motor slides into the coupler. I run a bolt from the bottom up, and then I nut on the top side. There's four bolts per jack. So then you tighten those nuts. We have a right angle tool here that runs to an impact, or you can use a 3/8 wrench or 7/16 wrench. It doesn't hurt to come back with a 3/8 wrench and double check, make sure it's tight. Okay, the next step I want to show is how to assemble the jack plate to the pre-assembled vertical. So the vertical has the girt tabs already fastened to it, and they're all pre-welded, the top hinges, and they're already marked out on where these jack plates go. There's a left and a right, so they're opposite from one to the other. And there's only 2 of these per door. So only 4 of the holes are pre-drilled, but each one of the holes in the bracket, all the screws go in each plate. So there's a total of 14 screws per plate. So just got done installing the jack plate. Basically got temporary bolted in with the SPAC screws. These are already pre-drilled holes in the plate. So the jam plate goes on the jam, either wood or steel jam, and they go on flush with the face of the frame over the top of the header or truss on top. 4 bolts through bolted, 2 through the jam, 2 through the header on top, and then 5 bolts through bolted the jam on both sides. It gets through bolted and nutted, and then torque tight on the back side. So the top hinge that's where the door hinges at the top. The horseshoe, this is where the jack pivots. This is where all the load of the door is at. We got trim on here, pre-trim this, just to get this a cleaner look. It's easier to trim now than it is after, trying to notch around all that. It's also easier to seal up. It's basically simple 4x2 jam trim. So then also there's 2 holes here, gives you options. Do you want to put the bolt in the most center and most meat of the column? Some situations you don't have exterior girts, so you'd want to go in this hole. Some situations you got a 2x8 column, you want to go in this hole. Some situations you have other frames, so you have options. You don't need to put 2 bolts, and you don't need to fill all the holes on the jam. Just 5 bolts, and you want to go those bolts in the most meat of the column. You don't want to drill it to the edge or just barely. There's a lot of weight, a lot of stress on these bolts. It's serious load. So, okay, so on steel buildings, We just have a simple 12 gauge 8x2 jam here. That's plenty good, obviously on up to 20-foot doors. If you get bigger doors, the load ratings change, so all the load's in the jam, so you can go to a 3/8 or quarter gauge jam. Also, I want to explain, you can bolt this or also could be welded. Very important when you're welding this jam plate, all the load is in the top hinge, majority of the load. That top hinge has got 4 holes. It's either going to get bolts or it needs welded all the way around that plate. So you can weld them, just needs to make sure you get a good weld. There's a lot of stress on that upper hinge pulling out. So all the load's going to be on your weld. Now that we have the jack plates put in place, we're ready for the jacks. I like hanging the jacks before the verticals, just so that way they're not in the way. They come either labeled right or left. So when the right side is when you're looking from the inside out. It's the right and then the left. So you want to come give me a hand? These trunnions go into the hole here. So you got to, it's about 120 pounds here, so they're not light. You want to swing the bottom out so it clears the horseshoe, and then you assemble the horseshoe plate. There's a serrated edge inside. I like to put that to the back side of the load, so that way when it pivots, it's not pivoting against those serrations. There's 3/8 by 1¼ inch, grade 8 bolts. There's 6 of them per horseshoe plate. I put the bolt in through the back side first, and put a nut. The guy on the bottom needs to just wiggle a little bit to make sure they line up. We'll go out a little bit. All right, so Dylan, I need you to make sure that's perfectly parallel, because there's some adjustment in this. This can move in and out. There's some adjustability with that, but once this is locked in, all 6 are tight, that's where the jack's gonna stay. So you want that perfectly level with the jam. Okay, does it swing freely? Okay. This is the connection box. This gets mounted to the wall as close to the pivot as possible. And you want the motor wires coming out the bottom of the box, so then your power and your signal wire comes in through the top. So over here is a graph showing the labels of the wire. That's on the power side, and then there's a Cat 6 cable that just gets connected in the box. So we'll go ahead and mount this box and show you the connections. Power cable has a strain relief already on it. All you gotta do is take the nut off, put spade connectors through, put the nut back in. It's already all pre-drilled, ready to go. Okay, so now that we got the box mounted next to the pivot of the jack with enough free space for the motor to rotate, next we're gonna run the cables from the box. This is the far side jacks. Control box is going. The customer wants the button in the box on the other side of the door. So we're gonna run the cables from the far side over to the box. We don't supply any of the cable straps or staples. We don't know. It's a fairly cheap, just a Romex staples, what I use. Just gotta make sure you run these nice and neat and straight. It's the #1 cause of callbacks is dangling wires. Wires dangling and wires loose get snagged, and snagged wires is gonna cause a door that's not gonna work. I also want to mention these Cat 5 cables. They're not the most robust connectors. So if you drop it in the mud, or if you're step on it or drive over it, the cable's more likely junk. So you gotta be careful. This Cat 5 cable is communication. It's not the most durable thing. So that's one thing, you just gotta watch the ends, not to get them wet, not to get them muddy, not to step on them and drive on them. Now we'll put the right side box on. So we got a nice clean look with the wires all out of the way. In the wall, if they want to cover the wall with sheeting, they can. Just a simple 2 screws in there. You can take this box out carefully, slip your sliding in behind. You can run these cables in Romex to to the control box. Prefer not to run Romex. If you could, run some strain relief holes in through the siding and keep the cables inside the wall, or run cables in behind trim or something else to cover them. Just had problems with guys snagging cable and communication, noise, things like that, and steel conduit. So if you can't avoid using conduit, that'd be perfect. Okay, so next step was mounting the control box, and that's got the control button. You want to determine which side the door customer wants the control box. You can do left or right. That's why the cabling is all labeled left and right. So you can put the box over there and run the long cables this side, so it's all vice versa. So what I do, the control box is somewhat heavy, especially the big doors. It's got the big power supply. It's very, very heavy. So I always just put a little keeper screw here, or a block or something there to hold it. There's no screw holes. You just, I just run a regular standard post frame screw, quarter head. Now steel frame, obviously you run a self drill screw, but I just run 4 screws, one each corner, through the plastic housing right into the wall. There's no pre-holes or nothing in there, so it's very flexible, and you just don't want it to fall off. More the better, I guess. Now that we got the control box mounted on the wall, I want to go over some parts and pieces of the control box just to explain to you what all is going on here. So this is the transformer. So this is taking 110 AC out of a wall outlet, inverting it to 24 volt DC or 27 volt DC. So this is the motor controller. So this is where pre-assembled motor cables come in through the top of the box. This is where they plug in. So you got your green, white, and black. You got your right motor and your left motor. This is all pre-labeled. It's all plug and play. So what I like to do, instead of having a big wad of cable inside of this box, I like to cut, being these are crimp-on connections, I like to cut the cable and make it so it's a lot cleaner instead of having a big spool of wire. Also, this is the LiftMaster wireless receiver for your remote, and then also your breaker to kill the power. Then also we have your battery connections, left, right, and also we have a jumper. So this sticker here shows the battery connections. So we can start there with the battery. I always start laying the batteries horizontal. They stay in the box better. They hold in there better. So I got a black terminal, so I want to take the black off of there's 3 wires connecting into the black. That goes to black on one battery. Then I put that back in the back of the box. And then there's a jumper that goes from red on one battery to black on the other battery. Before I hook this red up to the battery, I'm going to plug it in and I'm going to power up the transformer just momentarily. That way I don't get a spark. Because what you're going to do is you're going to generate a spark when you connect the red to red, because it's giving you a momentary short. You're basically hooking red to black until it charges the system to 27 volts. So what I'm going to do is I'm going to use 110 power, and I'm going to charge the system first. That way I won't get a spark and I won't burn my connector. You want to do that, make sure the breaker is off as well. I already checked that. Make sure the breaker's off. So now that I got power there, that won't spark. So everything's still off. So we can just go ahead and unplug it until we got all the other connections done. So then you got, so this cable here is going to my right motor. So I want to connect to the right motor. So just green, white, and black. Cut the length so that way it's nice and clean. Don't have a big spool hanging there. Then also, I want to orient my communication. And I always pre-label these so I know left and rights. So in case I have a service or something like that, I know which side is which. So here we got on our circuit, there's left written there and right. So they plug in to Cat 6 right underneath the motor controller. So that is our motor communication. Next, we can go ahead and program the LiftMaster receiver. So what we'll have to do there is we'll have to turn the breaker on. We can do that unplugged, it's just 12 volts. So you can turn the breaker on. Nothing here is going to light up. This never lights up unless you push this button. So you want to check and make sure you're powered on. Basically, there's LED lights showing on the bottom of the Robotech controller. This is the motor controller. The lights are on. It's showing right now orange, red, and green. At this point, that doesn't matter. We know we're powered up. So you want to take on the receiver, on the remote, create a random sequence of switches. That way it's not going to be a default sequence programmed to the LiftMaster receiver. In case you get a new one in UPS or something, the UPS driver will open your door by pushing a button inadvertently. So you just want to create a random sequence, the same on both typically. So then you're labeled open. Channel 1 is open, channel 2 is closed, channel 3 is stop. So channel 1, you want to press that and that's open. What I normally do is I program the green button as open. So you push that and hold that till the light goes off. That's programmed open. So then press the close button. So then I press the yellow, I make as closed. And then I press channel 3 is a stop. So I press red as stop. Just push the button until the light goes out. So now we're programmed. Well, this is where I'm cutting the wires and I'm making it to where they're cut to length. So that way we don't have a big spool of extra cable in here. So I'm cutting it to length and I'm putting a spade. There's a bag of spade terminals already sent to do that in the box. So you can crimp and make your own.
Just did. You said I went ahead
and cut those for the excuse me, left motor cable was too long, so I cut them to length and I put it in the box the proper, and I re-crimped new connectors. So I made a custom cable for this size door. So that way there's not a bunch of extra cable laying around. So yeah, you don't necessarily need to do this because these cables do come pre-crimped, pre-ended. You could spool up the extra length of cable, but I like to keep things neat and I like to cut things to length and make it so it's right. So, okay, so once the wiring is all done, we can go ahead and start on the frame of the door. So we'll go ahead and put the vertical in. So that's a long pin. There's long pins and short pins, so the long pins all go through the top. And these are 5/16 by 1 bolts. Okay, so once the verticals are set, you go ahead and set the laterals. Okay, so now that we got the verticals pinned in, I'm gonna show you how to put the laterals in. First, I want to explain to you on this small door, these only get laterals, no center hinge. Center hinge starts at 18 feet and up to 24 foot, still get a center hinge, but gets one piece lateral. So doors over 24 feet get a center mullion. So it's basically the same thing you got going on the jamb, just another set of girts on the other side and just keep stacking, keep going wide. The center hinge, you chalk a line, get that straight, 4 bolts, just like on the end hinges. So I'll show you how to assemble that, as well as assembling the center hinge. So in that pack, there's number 14 by 1 screws. These all self-drill, get screwed in through the brackets into the aluminum girts. So the top rail goes to the underside of the bracket. Then the rest of them you could put on top side and screw up from the bottom. So the top one, we're going to screw from the top down into the aluminum. And there's 5 screws on each end that go in. And the other thing is important, when you're putting self-drill screws in, not to overdrive them. It's fairly easy to strip them out. And so you don't just want to watch that. If you don't have a good hear for it or feel for it, set the clutch on your drill so it's not overdriving. And also you want it snug as well. You don't want to under. So it's kind of a little bit of experience there to get the feel for that. So next I want to show you how to put the center hinge in. This is on doors between 16 and 25 feet wide. It's got the same long pin as the ends do. You'll have the center hinge piece. What I normally do is I normally lay that in there, then I run the pin in it. And then I screw it to the lateral. And then also that gets a 5/16 bolt in the pin, same as on the end. It's same setup. These bolts are crucial. You don't want them pins falling out. And then once you're done with that one, you go on down the door. I usually start at the top and work my way down and do the bottom last. So when you get all the laterals done, before I put the bottom one on, there's these intermediate pieces that go up the center to keep the door from sagging, and that's what bears the load on the center hinge. So you'll have a bundle of these that are in the pack. So not all doors have this. This is only on doors under 24 feet and between 16 foot and 25 feet wide. So there's not all of them do, but if it does come with these, I'm just showing you how this goes together. Also 40-foot doors, things that have a bigger span on between mullions. Like I said, you'll have 3, 4, 5 verticals, main vertical beams, varies on the size of door. These are pre-drilled, so they're pre-drilled left and right, so they stagger up the center of the verticals. Some cases we're going to have a double bottom frame. Sometimes this piece goes underneath the vertical. If it's a double bottom frame, it's going to be pre-welded. And you'll see it'll be notched for this, and the bracket will already be pre-mounted for you. You mock it up, you'll get pretty quick how it goes. So different variations. We also have the 2 beam setup on the bottom, aluminum angle beam on the bottom. These are all in the assembly manual. They all pretty well the same basic setup. Yeah, these are 12x1 screws, so as you know, you got to watch your torque on your drill, and it don't take much to snap. So okay, so we just put the bottom piece on, showing on a smaller 16-foot or 12-foot door like this, which is just the standard 4.5-inch I-beam. So when you get into 30, 40, 50, 70-foot doors, obviously that's not going to work. So we do this as our subframe to a certain length, to a limit. But when you get into 2 beams, spans, things like that, we have 5 different options. I want to show you the main kind you're going to see. So this is basically the vertical, okay? And which is this part here, okay? So this is going to be option 1. So this would be corner. So you'd have same screws go in here. Option 2, which is a double aluminum tube. Option 3, and we actually have 2 different sizes of this. We have a 10-inch and a 12-inch, and that goes there. So it gets mounted same way. It carries more load. Then also with these options, with this tube beam and this tube beam, there's this extra angle gets fastened there to carry the extra load on each one. So this gets fastened to the face, and then this gets screwed to the tube beam as well. Then when you get into the tube beams, you use this piece of angle that's included. That gets put in on the back side here. And that gets screwed to the top of the beam, whether it's steel, aluminum, or aluminum. And what that's for is this is where the trim profile goes and covers over here, up this, and then also the steel or the cladding siding goes down, and that's where you fasten your cladding. So this gets screwed in every 2 feet across the bottom. And the same number 14 self-drill screws. Sometimes you have to pre-drill this to get the screw in, especially in the steel. Okay, now that we have the door framed, we're ready to hook it up to the loose jack. So the way we send them out, sometimes they're going to be extended out long enough to where you can hook them up. Sometimes you're going to have to extend them out because they're too short. So how you do that is I've already turned the breaker on inside the box. So we're powered up, ready to go. So what you have to do, you press open, it's not going to go. So you have to press close, create a false home. All right, now that we got the frame all assembled, ready to go, now we need to hook the jacks to the frame. So I've already powered up the breaker. Everything in the breaker is on. The controller lights are lit up. So what I need to do is I need to home the door, or home the jacks. Now how you do that is just press close. You press close until the jacks fully seat to a preset amp limit and they click. So if I press close again and I don't hear anything, that's a good thing. That means it's homed and it's ready to open. So now I can open the door or open the jacks and extend it so I can hook my pins up. Easiest way to do this is break the powder coat on that. Break the paint loose. Very crucial. Pins cannot come out, ever. Bad day if that pin falls out. And there's holes on this bolt. You can go either way, it doesn't matter. Just basically which way is easier to do. Okay, so now we got the jacks hooked up. Basically all we're gonna do is we gotta create the home. So the door will come closed and it'll find a home. It'll sense that amp load and stop, and it'll pull it tight, perfectly tight every time. So basically check both sides. We are perfectly tight. The door is pulled tight to the frame. Now this gap, this will be closed up with seal. So we'll get to that later. So go ahead and we'll press open. Now what I like to do is, just in case something's not right, I go about 2 or 3 feet out and I press stop, just to make sure the stop button works. So you want to be ready to stop at any moment. You want to watch for cables. You want to make sure this isn't getting bound up. Everything's going to be stayed free through the pivot motion of the door. Of course, you want to stay over by the control box. In case something were to go awry, you can stop it. It's the first time we've had this going, so we just want to make sure. So it gets all the way open, it'll stop on its own. Slows down and stops. It clicks, you'll hear the brakes click, and that's the motor, that's what holds the door, keeps it from coming down. Okay, so next we're going to put the bottom seal on. So easiest just to leave the door open part way. And I usually use black screws. We use this plastic retainer. Goes to the flush of the edge, outside edge, to the side, and you fasten it on the inside. You want to leave your first screw at least 2 inches in because the door overlaps 1.5 inches. So whether it's a tube beam, C-channel, no matter what the bottom is, it all gets fastened the same way. The aluminum big C-channel or the aluminum tube, you unfortunately have to pre-drill that. Aluminum is just so thick. So this, self-drill screws go right in. So, and you also want to screw this at least every foot. This will expand and contract, and it'll get all bubbly and wavy in the heat. So you want to make sure this is secure, because there's some tension on this. It'll want to pull apart. So you want to screw it at least every foot. Okay. Then we slide the bottom seal in. So a little trick of the trade is squirt some WD-40 on there. Just start it in one end and It's a two-man job. You got to have one guy feed it and the other guy pull it. And you're going to want around 4 to 7 inch length. These come extra long. You want that much hanging past, and you're going to tuck it into itself. So next you want to make sure the door is secured square to the opening. The next step is actually going to be putting the sheet metal on the door. So before you do this, the crucial part is make sure the door at the bottom is centered in the openings. You don't want the jack pins and pivots hitting the jamb on every operation or have to move it. So this door actually needs to get pulled about 1/4 of an inch. So basically with a good tug, you can pull the door to where you need it to go. Keep your hands and fingers clear and press close, and the jacks themselves will actually hold the door square where you want it. So this setup here on this small door has just a standard wainscot transition. It's in our profiles, last sheet of the manual. It's got all these trim profiles you need. So I start with the bottom trim. So on this door, it's going to be just a simple angle. Like on the two beams and the bigger beams on the bottom, there's a Z trim that needs to get put on first, and that gets folded on the ends. This I just put on flush with the end, and then I put it on to where the bottom, this bottom return leg is flush with the bottom of the door frame. You definitely don't want this dragging, because then that just makes noise. So you want this at least 1/2 inch to 1 inch off the ground. Then I go flush with that end, and then I put a screw. I just put temporary screws in it to hold it. So now we are ready for measuring out girt spacing on our panels. So these I-beams, you got to be careful. There's a web in the center. So you want to go above and below that web with your screws. So I always measure from the base, and then I always put my bottom row below the web so that way you don't see the screws on the inside. Then I go below the web here, and then above there I go above. So I measure from the base angle to each one of these. Check the ends, what that length is. I check the center, and I check the far end. So I make sure everything is going to work out, because I pre-punch all the steel, and then I set everything up, not having to chalk or do any marking or measuring once I punch the metal into place. So let's go ahead and start our first sheet. You want to measure out the width, because you want to rib either on the edge or away, just kind of like a corner trim, because it'll get yourself in trouble when you go to put your vertical frame cover on. So you want to go, this is the vertical frame cover. It covers the end of the door frame. This is on the last page of the assembly manual, this profile. So it's all the same on pretty much all the doors. So you cut this the same length as the panel. Unless you get the two beam situation, you're going to want to notch that on the ends, and I'll show you how to do that as well. So you want to cut this to the length, or notch it to the length of the steel panel. I want to just show you how the different tube beams trim outs work. So there's different profiles of trim, obviously, for the aluminum tube and the steel tube. This would fit the aluminum. So you have your vertical would be back there. You'd have a different dimension here, cover the steel. This is 7 3/4. This is 4 1/2. But anyway, then you also have this 1 1/2 by 5 trim. That covers the face of your tube, and then you fold that back 1 foot here, and that's what covers the end of the tube, and that gets self-drilled as needed in the tube beam. And then the vertical frame cover trim comes in, And that encapsulates, so you'd have this would be trimmed out, and then this encapsulates, so this is 5 1/4 cut here. So then you screw this just like we're going to show you on this door. But I just wanted to start here and show you different trim outs for different size tube beams. So everybody has their own way of doing things. It's the way I found it to be the cleanest. So let's go ahead and put our vertical trim cover on our door display here. So now we're just going to cover the end of the door with, this is our basic simple frame system without tube beam or anything. So it's just a square factory edge at the bottom. First thing you want to do is you want to crack the door. So you're going to need to get it inside the back side of the vertical. So this profile here, this goes on the back side. So I'll go ahead and crack the door, and then we'll go ahead and put that on. Mike. So you want to screw the face in line with all the other screws here. You don't want screws in the back side because it's just going to hit the building. So what I do is I put screws in that 1/2 inch return leg on the vertical. You'll see what I'm talking about when you see that vertical. But there's a 1/2 inch return leg on that vertical. So you push it tight, so you push it out so it's square. And then at every girt, same thing just like on the face, you put a screw right here on the edge. Do that on both sides at every girt, and vertical trim's done. After you get all the metal on the building, all the panels on, the vertical frame covers on, you have 2 options for top. We offer a heavy-duty black tarp with a stitch. This can go on your chalk line up here. This is 5 1/2 inches, so you're going to want to stay up here with your metal and your trim. So this goes at 6 inches. Then that gets stitched in on every rib. There'd be a J trim up here, and then you would stitch that to every rib through your hem, and then you would basically fold the ends to your framing, keep the birds and things out at the end, keep birds from flying in through the end. Last 2 pages of the manual. There's top trim profiles. It's top trim that goes on the building, and top door trim that goes on the door. So what I do is I fold the ends so it keeps anywhere, sheds the water for one, also keeps it to where birds can't fly in there. And then fold the ends on the top trim. And the base of this top trim can be put on prior to the door getting installed. If you fold this, you're going to want to stay, with this fold, you're going to want to stay 3 inches past beyond the opening. And you can put this on prior to the door getting installed. And if we're installing it or somebody else is installing the door, you can pre-trim your building with the top trim. I always recommend you fold this over and you leave this fold at least 3, if not 4 inches past the opening. Give us room for that top hinge to be put on. Get a nail, screw this, and then your upper steel sits down on top of that. So then when the door runs, when the door operates, this stays on the building. So this trim goes up underneath. It moves with the door, and this trim goes up underneath the top trim when the door runs. So you got to be careful not to get any trim in the way of the top trim, because it'll crash and bend and make all kinds of noise. So next we're going to go ahead and put the bubble seal on. You want to put this on the door. You can put it on the building itself, but the problem with putting it on the building is guys can rub and catch it and it can tear, whereas when the door's open, it's usually out of the way and way up in the air. This goes on your jambs. Just run it nice and neat, just right to the edge, about a quarter or so in, right to the edge. Just keep it consistent. Make sure you press it on. That needs to be put on at 50 degrees or warmer. You can do it in 30 degrees, but it's not going to stay. Unfortunately, the 3M just doesn't work in anything above or below 50 degrees. And then you can put the top seal on, same thing. Goes right to the top of the door, just right along the top rail. To conclude, that is how you install an incredible swing door. Now you know how, and we'll see you on the next one.